Manufacturing and maintenance are two sides of the same coin. How an aircraft is built sets the stage for how it must be maintained. High precision, well-controlled manufacturing reduces wear, minimizes unexpected failures, and makes maintenance tasks more predictable. When parts fit and finish are done right the first time, maintenance crews spend less time troubleshooting and more time on planned upkeep, which boosts reliability and keeps fleets flying longer. The way parts are made, their tolerances, surface finishes, and materials directly influences how inspection and repair are done. If a panel is drilled with tight tolerances and excellent hole quality, inspectors can use standard NDI tools effectively. If manufacturing variability creates rough surfaces or hidden defects, it can hide damage and make repairs more complex and time-consuming. In other words, good manufacturing simplifies later maintenance work. Aircraft and their parts must meet regulatory certification before they can be sold or operated. This means factories must prove that every step of production complies with standards like AS9100 and the airworthiness criteria set by authorities such as the FAA and EASA, including validated processes, controlled procedures, and documented evidence that parts are made the way they were approved. Before an aircraft can fly, manufacturers must issue a conformity statement showing the airplane was built in accordance with its approved design and quality system. After that, the regulator grants an airworthiness release that allows delivery and operation. These releases depend on traceable manufacturing records and inspection data, so authorities know the aircraft truly meets safety standards. Sometimes problems in service aren't due to age or use, but to how something was made. Hidden defects, material issues, or poor assembly can surface later as corrosion, fatigue cracks, or unexpected wear. When these are traced back to manufacturing, they trigger maintenance alerts, service bulletins, or even airworthiness directives from regulators to fix or monitor similar aircraft worldwide. One of the most powerful aspects of aerospace quality systems is the feedback loop. In-service findings, such as inspection data, repair trends, and defect reports, feed back into manufacturing to improve tools, processes, and specifications. This loop creates a culture of continuous improvement where real operational experience helps refine production and reduce future issues. That brings us to the end of Module 4. In this slide, you will find some of the references used in preparing the content and some additional links and references for further reading.